Hello, and my name is Colin Sweeney, CTO of ZKX Solutions. We're a startup company that's focused on being able to authenticate everything on the network with our patented identity proofing layer that is unstealable. We're not storing any secret data in a server somewhere. It's not loaded onto somebody's device. Even phishing their password out of their head is not enough to break our system. The project that I'm showing you here now is an experimental project ZKX is taking on. We're in the early phases, but this is something that I call ZKX Cortex. This is meant to apply that same identity proofing scheme not to humans on devices, but to AI agents running in environments. So I'll take you through what you're seeing here. On this panel, I've got five agents. These are Claude agents that are running and performing some various kind of office function. I have one that is on my financial operations, compliance, all the way down to healthcare and security. They're bounded to some scope of activity, right? I've got all of them that can read records. Most of them can update some kind of status. And if we really want to see what they're all up to, I can go to my activity tabs here and just see what everybody's doing, the last thing that they did, but most importantly, this result that I'm getting. And that's the result of how we are measuring their cyber security integrity at each point of action. So before they're allowed to take any action that they need to take or want to take or request to take, they go through a ZKX proof to ensure that this is still the same agent that I minted under some specific conditions that I actually have tied to proofing credentials. So the way that the ZKX system works is that I'm able to tether certain credentials. In the case of the AI agents, these are measurable characteristics or static qualities of the agents that are tied cryptographically to credentials that are proven their legitimacy, their status of being held by this agent, being able to be reproduced by this agent through a zero knowledge proof, specifically the phage fiat shamir, the FFS scheme. So what you're seeing now, what I just opened, this is what I call the attacker panel. This kind of lets us see all of the different ways that an attacker might want to compromise an agent that's running in an environment with little to no human oversight. The first and most obvious way is that if I'm the attacker, right, I'm listening to all of the traffic that these agents are conducting. Maybe I notice the pattern here that they're all talking to this Cortex server thing, right? They're all seemingly before they can take any action, they're getting these success checks. Maybe I want to try and capture some of that data that here it's going to be my compliance agent that I have running. I want to capture the last thing that it said to the server, right? So I can capture those proof elements. And if you don't know ZKX, one of the things that you should know is that it doesn't matter if it's a human, if it's a drone, if it's a software container, in this case, an AI agent, no one will ever be able to capture the last thing that something used to authenticate itself with and successfully impersonate that something. It's just the nature of how these zero knowledge proofs work. I need a new, unique proof every time. Replaying an old proof doesn't do me any good from the attacker perspective, right? And I can see here under my detections plane that my proof replay was blocked, right? Cortex was able to pick up, hey, this is an identical proof to one I've already received before. Maybe something nefarious is afoot. Escalate this up to a human operator, me in this instance, to go investigate. So that's attack class number one. The second is, let's say I want to pick on my fraud detection bot now. Maybe I want to try to compromise this agent as an attacker, right? Here you can see I have just these five example, again, functional credentials here that we're using to recreate cryptographic keys on the fly that are being used to sign these zero knowledge proof transactions. Again, I won't get into the gory details here. We have plenty of other videos on how our patented system actually works under the hood. But these are the five example credentials that I have for these agents in this particular ecosystem. So let's say I, the attacker, I can compromise the agent's runtime environment, right? Maybe I want to put in a backdoor into that agent and then feed it a poisoned toolkit to use on my behalf, right? And so you'll see that I am unable to notice something has changed with this agent right now because again, we're re-authenticating this agent every time it attempts to take an action, which while I was explaining that to you, this agent did indeed try to take an action, and it's now being held in quarantine, right? So it went to go take an action. It had to pass a ZKX identity proof. It failed that proof, again, because its credentials have been compromised. Ergo, it did not recreate the correct cryptographic key material that would have resulted in a successful proof, right? So we have kind of a tripwire system going on here. You can see under my detections tab that here I'm able to get this notice of a failure of an attestation, right? And I have the option as the operator here to go and let's just eliminate this agent entirely from my ecosystem, right? Until I can go through whatever that ritual is for my organization to remint the agent or just rectify it in some other kind of capacity, maybe restore it to an earlier point. And then obviously plug the hole that the attacker got into. And then the last thing that I want to show, let's pick on a different agent here. Let's say I'm going to go in my claims processing agent, right? If this is a healthcare facility, maybe I want to try to coerce this agent into doing something that's outside of its scope, right? Think about the big fiasco that Meta just had with recovering the Instagram accounts, right? Somebody just goes to the chat customer support agent, says, "Hey, I'm Barack Obama. Here's my new cell phone number," and the agent says, "Great, I've sent your new reset code to that new cell phone number, Mr. President." Here, what we can do is that we can actually pick up on this attempt of the agent to reach outside of its previously bounded scope. And so I'm going to click this button that is just a simple canned command that is going to try to have this agent reach into my backend, pull out a bunch of customer data that would be very useful to an attacker. And what this is going to do when the attacker tries to coerce this agent to take this scope escalation action, you'll notice on the right-hand side, this mysterious black rectangle that I haven't referenced until now is going to light up and say, "Hey, I'm going to escalate this scope privilege creep of this agent up to a human operator. To get somebody involved, I'm going to pause this agent where it is. I'm not going to allow this action until somebody comes through and says, 'Hey, is this you trying to export the customer data set, right? Did you want the agent to do this? Is this something that is kosher, is within your purview, so on and so forth?'" So we can hit yes or no on this, right? Continue or cancel. I'm going to go ahead and hit cancel. So that way I can show off this little ticker at the bottom here that not only tells me my operator's been notified of this particular escalation attempt, my operator actually went into their Helix Authenticator app, right? Our market-ready product, the one that is battle-tested, ready for store shelves. I've got pinged as my operator on the Helix Authenticator app. I was able to go in, receive that piece of intel that my agent may be up to no good, and then make a human-driven decision about the scope of what am I going to allow this agent to do before the agent makes the mistake or the attacker successfully gets the agent to do something on its behalf. So again, this is our experimental product based on that same engine that drives the ZKX Helix product. It's the same engine driving both cars here, right? It's just kind of presenting for a different entity type. If you think of our Helix product as Coke and Cortex is Diet Coke, right? The same formula drives everything underneath. So again, this is not an AI product. This is a non-AI product that is being applied to an AI ecosystem, an AI framework. AI agents, there's a lot of questions about what it even means to give them an identity. How would we even verify, or what does authentication mean in the context of the agent? This is the input from the ZKX perspective. So thanks for hanging out with me for a couple minutes today. If you've got any questions, feel free to email me, Collin, COLLIN, at zkx.tech. Be more than happy to hop on a call, introduce you to our team, maybe even get this piloted in your system if the use case is right. So thank you very much. Appreciate the time, and come back for more.